MRI safety is at the forefront of our profession. It starts with protecting Zone 4 and is why the ACR recommends using a caution barrier at the Zone 4 entrance. But what good is another sign in a room full of signs? Well, Aegis has created the perfect solution with TechGate Auto. TechGate Auto allows more focus on the patient and less worries about someone entering the room without being cleared. If you're serious about MRI safety, use the link in the description below to find out more.
Zone 3 Podcast, I am Robert.
Yes, and I am Reggie.
And today we are joined by a field service engineer. It's Todd Bedoin.
There you go.
Did I pronounce it right?
Yeah,
it's that French. I don't know.
It is French.
I'm not bilingual.
No, I'll answer to it.
But you play hard to get, Todd. We've been trying to get you on for a bit. You're a busy guy.
You caught me at a moment of weakness. Committed.
Well, first off, you're a field service engineer, and that's what you're here to discuss today. But before we get into all that, kind of give your background as far as like a little bit about yourself, where you're from, and how you came to be here in Arizona.
Sure. I'm originally from North Dakota. Born and raised there. I came to Arizona to attend college. I went to DeVry, got a bachelor's of science in electronic engineering. From there, I switched to took a position in semiconductor industry, and I worked that for several years. That business pretty went flat, right after Y2K, and kind of transitioned into healthcare from there, and I've been in healthcare ever since then.
So was it a conscious decision to get rid of your accent? Because I don't hear an accent.
You will. So it'll come out. So don't worry.
Okay.
What kind of accent do people from North Dakota?
You've ever seen Fargo?
Yeah, you've seen.
Don't
Fargo?
you know that type of?
Oh, like a Canadian type of style.
It's pretty close to Canada,
Kind
so
of
it's,
like
okay.
that. Just watch the vowels.
do you
All right.
apologize a lot, like
Yeah,
those
I do.
Canadians?
Yeah.
Sorry, Canada.
Sorry.
Well, like we said, you're here as a field service engineer. We're kind of curious. You said mentioning school, you went to DeVry, and how originally it wasn't healthcare you thought you'd get into. How did you get into healthcare?
That was kind of like, so semiconductor industry went very flat. I worked field service my entire career. The semiconductor business went really flat after Y2K. So there was a big buildup in there. Everybody got laid off, and then healthcare seemed like a pretty safe business to get into. There was still field service. It was a very difficult business to get into. It seems like you have to either come right out of school and kind of get into healthcare in that line of work, or like out of the military into it. But I got accepted by a small MRI manufacturer called Phonar, and was trained by them, and that kind of launched my career into healthcare.
He's a humble man,
service.
and I'm glad you brought that up. So Phonar, let's talk about that.
Let's talk
so
about
it was
Phonar.
small, right?
was
But not
very small.
really. When you
He
think
was-
about the person who was part of that.
The person who started the company, Dr. Raymond Damadian invented MRI.
Right.
He was the first man. He created the Indomitable, the first MRI, and he was the first one to extract an NMR signal from a human body.
So you were trained directly under Dr. Damadian, the inventor of MRI.
Yeah, his team.
Look how humble this man is.
Right.
Just like trying to slide that in like it's
I
nothing.
just kind of slide it in there.
Well, give us some juicy gossip about Dr. Damadian. We just
Well-
apparently, for the record, he just passed away, unfortunately. So
Yeah.
we'll probably put a rest in peace right there.
Sure.
But
he's was a brilliant man. I met him a few times. Was trained by his team. Learned a lot of my MRI physics from them, like basic MRI stuff. Spent like several weeks in Melville, New York, going through that stuff, and then hands-on experience on their equipment. Super smart guy. I mean, how he came up with that is incredible,
Just
right?
have to think
it's just-
differently, right?
Yeah, and it's just like some of the stuff he educated me on, doesn't have much relevance in
well, for
my
example,
work. Well, he was very proud that he came up with the equations for like T1 and T2 relaxation times and had us memorize those.
Right.
It doesn't do me a lot of good changing parts out in the field, but
Right.
it's interesting tidbits to know. But there was some very good training in there. Like I discussed with you, they trained us, what gradients are doing what during what times of the scan. That's proved fruitful in my career, is to figure out like what gradient's causing the problem. You'll see gradient collapses on some scans when you have hardware issues and stuff like that. Diagnosing like spike noise and stuff like that, that helps out to know stuff like that. But yeah, he had an interesting piece of machinery. It was an upright scanner, and there's still several out there, and the company's still viable today. And but yeah, that was my little start into MRI.
Oh, his name would be all over my resume. All right, so then you went from there to what then?
To GE Healthcare.
Okay. And then you worked with GE for how many years?
13 years.
Okay.
So until like about a year and a half ago, I joined the Mayo organization under the healthcare technology segment. It's kind of split between biomed and imaging, and so I'm on the imaging side. Responsible for taking care of the MRIs, everything kind of associated with those, along with the PET MR downstairs in oncology.
Nice.
Now, because I imagine your knowledge initially was pretty GE strong. So was that difficult switching to different vendors, or is it a pretty easy transfer?
No, that's part of the imaging business as far as field service goes, is doing what's called multi-vendor service. So you do actually, they'll write contracts on competitors' equipment, and they have a very strong business, and they actually have their own machines in which you get trained on. So you don't really go to like a Siemens training school, but GE has Siemens equipment in which to train you on. So it's not completely foreign to me, but I still, my coworker Jesus, he's very good at filling in the gaps for me. An MRI is an MRI. They kind of all have the same pieces and parts, maybe a different name to them, a little bit. They all kind of function the same. So,
well, from an MR tech's perspective, that's kind of how I train people who are new to a new vendor. Is I just say this is basically the same car. You just have to learn where this car's turning signal is, or windshield wipers,
where the buttons are.
Yeah, exactly.
So yeah, exactly. So
so it translates the same.
Yeah, it's pretty much the same stuff. It's just, what do you call it? There's some kind of monumental differences between the scanners and of component locations and how they do things, but in the end, they're the same subsystems.
So I imagine a lot of people in your field probably went through the same sort of training where they got on with a vendor, and through that's where they gain their knowledge, and it just kind of translates throughout.
Sure. So I think that's kind of one of the better ways to get trained. As a vendor, you see kind of all problems. You see a large volume of problems. So that's your job, is to go out there and solve them with the support of the OEM, which should be able to solve basically any problem on that system.
And one thing I'm curious about is the requirements as far as certifications, credentials. So like any field service engineer, do they all have the same degree, or?
No.
Right. What is a field service engineer?
It's a catch-all, man.
Right.
You kind of, if you can resolve a problem, you might have a good chance of surviving in that field. But the problems can be complicated. I mean, we deal with mechanical problems. We deal with environmental controls, electronics, electricity, just incoming power, stuff like that, networking problems. You kind of touch base on like everything, right? And having a little bit of knowledge of all of that stuff makes for a better, well-rounded service guy.
That's why I always look up to like you guys and admire you, really, because I imagine you have a better knowledge of the physics than some of these techs do.
Right.
Certainly some of these doctors. Right. And the way you just come in and fix a problem like that when we're just staring at a blank screen, like we rebooted it. Beyond that, I don't really know what to do.
Right. And then sometimes, you really don't need to reboot. It might be, like different scanners would tell you, I have a bias fault, and that doesn't require a reboot. It's telling you that the coil's not connected, or there's a problem there.
Open loop or something.
Yeah, you got an open bias fault or a short. That's even worse. It's just like, okay. It's kind of like that insurance commercial, where you've seen a thing or two, you kind of know a thing or two. So, it's just like you've been around it long enough, you can identify these problems pretty quickly and solve them pretty quickly.
So experience is definitely valuable.
Absolutely. I think it's one of the biggest things to have.
And it's also, imagine, a team effort, because I know you're surrounded by a lot of smart people as well.
Absolutely. My career has been pretty blessed with being around very knowledgeable people, and having them mentor me along the way has been very instrumental in my success.
Yeah, just
So,
collectively, you guys are able to overcome.
absolutely, yeah. And I've worked with some awesome people in my day, and it's really helped me. And I share that with my coworkers. So, whatever knowledge I have, I'm not going to harbor that. I'm going to actually disseminate that amongst them.
Right.
From a tech's perspective, I would say the same is true, right? So we
for sure.
train from each other. We're always
Right.
training
Right.
each other.
Absolutely.
New hires,
I'm like-
and just
Because sometimes there's no right or wrong way to do this.
Right.
And it's just like this way might be just a hair bit better. And it's
Right.
like, yeah, sharing the knowledge is instrumental, I think. So
And is there a, like Robert was kind of asking before I interrupted, like a career path? Like, do you just go to school and then you just jump in and you just off to the wind?
man, actually right now, this field is really short of people. And like my employer actually is providing education for people if they want to sign up.
Oh,
You can get free education, and they pay for it if you'll come to work for us. Just trying to kind of get more young people into this kind of business. There's a true shortage there too.
for sure.
so are they actively recruiting, or are they just
Sure.
Kind of, okay?
Yeah, and they've set up programs. One of them's at Mesa Community College, I believe. They'll pay for your tuition and stuff if
Oh,
you want
wow.
to get educated. And like last I heard, they got no takers.
Hopefully that changes. Well, I'll try to find the link and we'll put
Promote
something in
it.
the description.
Yeah. But yeah, it's we deal. Most of my coworkers are either had an electronics background or come out of the military with some sort of electronics training out of there. Just guys that like to kind of turn wrenches, but you get a little of electronics in there, and you get a little
Right.
mix of this stuff. And one of my coworkers, he's now retired. He called us perpetual tinkerers, and I thought that was a good
I like that
analogy
too.
of
Right.
how we work. Just always kind of making things a little bit better, and that kind of attitude helps.
I can imagine you as a kid always taking your toys apart and putting them back together.
Yeah,
Right.
destroyed and rewired all kinds of stuff.
Everything. Huh?
And but
I call those kids nerds.
Yeah, but my dad was super helpful about that. He went through like parallel and series circuits with us when we were little
Oh,
kids. And
nice.
my dad was self-educated. And, he started his own businesses and stuff like that. And he was always learning more, and that was
Oh,
very.
that's
Those are the
awesome.
smartest people. I think the ones that are self-driven for
yeah,
sure.
absolutely.
Right.
So yeah,
Man.
so yeah.
Well, go ahead, Rob.
Well, with like the evolution of your career, does
Mm-hmm.
it usually start off as modalities? Like you start in X-ray, and then you'll move up to CT, and then MRI.
They like the
Some of the older guys, seasoned guys, I should say, let's call them that.
Right.
It started out kind of like that because like MRI is kind of like one of the last modalities to come into play here.
Right.
So most of those had started out in like ultrasound or X-ray and worked their way up. I didn't. I just kind of jumped feet first right into MRI.
That's a flex right there.
I don't
Todd.
know.
Yeah. You put Dr. Dominian's name on
Yeah,
that resume.
well, one of my former coworkers called MR many regrets, and after a few years of working in that line of work, I see where he got that from. So,
Right. It's just so many moving parts. So many, it's, there's three sources that were, there's multiple sources that we're using to acquire the picture. So many things can go wrong, right?
Absolutely, and it's to me, it's amazing that the thing works at all.
Right.
If you really look at it, how many subsystems are involved with this, and
Right.
how to keep everything timed perfectly, it's amazing that we generate images.
For sure.
So.
It is.
I'm kind of curious on where to start off as far as like the actual diving into what it is that you do on a day to day. We can talk about like the installation of the magnets, doing
Sure.
upgrades and whatnot, but I'm also curious about just daily like troubleshooting and stuff like that.
Sure.
Probably like, and then also preventative maintenance, identifying problems. We hope to cover all of it today, but
Sure.
where do you think would be the best?
Wherever my day-to-day stuff is
You're like that date that says, I don't care where we eat.
right. It's like, hey,
Right.
this is whatever's going to come my way today, and it's
Yeah.
all reactive, So preventative maintenance is a scheduled kind of thing,
Uh-huh.
but most of our work is reactive. Techs have a problem. We can't figure this out. We don't know how to do this, or this is broken. This thing fell off, or
Right.
that thing got jammed through the wall.
Right. Oh, God.
And it's on a case-to-case basis, but would
Sure.
you find that a lot of these things are something you're able to remote in and resolve, or do you prefer to be more hands-on?
We use a lot of it is hands-on, but we do use our remote capabilities quite a bit.
Nice.
And that's very helpful because scanner time is very difficult to get.
Would you consider that the hardest part of the job?
That's a very difficult part of the job,
Right.
is getting scanner time. MRI is not the fastest thing in the world. If I have to do a QA on something, it takes time, and it's
Which costs money.
Absolutely. And you take the table down, you guys can't set the table up. I'm going to tear it all apart and do my thing. And it takes, 20, 30 minutes of your day, and it's disruptive. So if we can look at things behind the scenes, we can dig through error logs. Like on the newer stuff, I can change like destination nodes and stuff like that without interrupting you guys, which is very helpful.
For sure, all on the back.
So on our end, would you find that there's things that we can do to kind of help make your job easier when problems do arise?
Yeah, like capturing, or I don't know, like capturing certain type of data, or describing the issue better.
Doing just a screenshot of the
like
error
like
code.
the like Siemens likes you to do like a save state on there as soon as the problem arises.
Right.
The problem with that is it can take you 15 minutes to do this, right? So that nobody wants to get that done. So, but it being letting us know in a timely manner, so we can like denote, because the error logs are huge. It can take it dumps a lot of data to figure out what was the root source of the problem. So if we have a more definitive time of when the problem occurred, then that helps us sift through that data a little quicker. But as far as, it's all case by case basis, I think. So
what would you say is some of the most common problems you come across, and what are the ones that keep you there overnight?
The most common stuff is like coils. They're used and abused the most.
Pins,
bent pins, and stuff like that. Some of the stuff that keeps us there overnight are some of this stuff that just doesn't go right. I mean, we have a lot of jobs like that software load that we stumbled into, and it's the ones that there's no like knowledge base, like nobody's run into this before, and then you're stuck trying to figure this stuff out and sort out all of these things. That really eats a lot of time. And when you're doing something and the calibration takes 4 hours, you're stuck there for 4 hours, and if it fails, you're zeroing out and you're starting all over. So that happens a lot in MRI.
Crossing your fingers.
Exactly.
For 4 hours.
You're like, I hope this works this time. And it's a good time to go get lunch, I guess. So, because you might be there for a while. And that's MR. I mean, gosh, we've worked on problems for days, months at a time, and it can be long hours late into the night.
Have you noticed that as the technology has kind of grown or changed, that your job has gotten a little bit easier, or has it gotten harder because there's more components?
Some of this stuff has gotten easier, but it's also created more problems. So the hardware on the machines has gone through like what I would consider a consolidation. Instead of having huge amounts of chassis, all of these boards in there, that might be condensed now to one board. But everybody's kind of trying to improve these things all at the same time. Like we had an escalation once, and it turned out, there was like spine images were bad. And it turned out that they were monkeying around a little bit in the software with pre-scan times. And so there's muxing that goes on when you guys select the channels that you want.
Right.
There was a mux in which the settling time wasn't long enough for that mux to settle and select the proper channels, and the software was getting ahead of that. So at the time, all your channels might have not been turned on. You get
during pre-scan.
Because that's where you can save the most time as a manufacturer, is cut your pre-scan time. Your scan time's fixed, right? There's nothing you can do about that.
Right.
But there's tricks the manufacturers use in pre-scan to kind of shave some time off of things. So they'll skip TG.
A transmit gain.
Transmit gain.
Yeah.
So instead of having that, what's called a fine-tune gain, they'll do a fast TG. They'll take big steps. It's close enough for clinical imaging. So like when we run service stuff, we'll use a fine-tune gain. It steps very slowly. So instead of like your pre-scan taking 15, 20 seconds, ours might take 45 to 50 seconds, just to step through this and do a temperature calibration and all that stuff. So that's all the stuff like in service that you guys never ever see.
Right.
So
Cool.
yeah, but the technologies both like some of the automation has gotten a lot better. So I've been doing MRI for almost 20 years.
Yeah.
Like calibrating eddy currents used to take us a day, 4-6 hours, and if it failed, you start it again. Now it's put the fixture in there in 30 minutes, it's done.
Right.
So in that aspect, it's a trade-off, but yeah.
Right. Some of the newer scanners are boasting like almost zero eddy current issues too, that I've seen. Like Philips, maybe with their new 3T that we did. Check out that video.
Mm-hmm.
Their diffusions. Oh my gosh, like eddy currents. At least I haven't actually used the scanner, but the demonstration was amazing.
Yeah.
Just don't have to even worry about that anymore.
Yeah. I mean, it could be that just they're compensating very well
Just
for
really
them.
well, right?
I know the general has done a lot of oscillatory calibrations as far as eddy currents go too. So
It's getting better. Right?
it's getting better.
Right.
Yeah, it's getting better and it's getting faster.
Right.
So yeah, and that's what we're here to get done. So
Right. Nice.
oh yeah,
Because I guess time is money, right? At the end of
Yeah,
the day.
For sure.
absolutely. No.
Ask any MR manager about that.
Mhm.
Right?
Well, as from a text perspective, because I'm curious, like some jobs will record daily values, right? And some won't. They'll do weekly ones. And so I'm
Mhm.
wondering what the importance of that is and how that affects what you guys do. And
So are we talking like QAs and stuff
Yeah,
like
QA,
that?
QC.
Okay, yeah. So we're trending the machine. So we want to make sure that we don't see a deviation going one way or the other. So say you're trending your RF, your TG, your transmit gain.
Mm-hmm.
Okay, say it's 123 and it's been 123 for 6 months. All of a sudden it starts to trend up 126, 128, 129. What that tells me as an engineer that your RF amp's going south. It's getting soft. So because it's losing power, it's going to make your transmit gain go up. How that affects you is that transmit gain is part of your SAR calculation. So you might be SARing out for no reason whatsoever because the system's just compensating. It doesn't have a feedback system, right? We're just throwing RF out there. We calibrate the amplifier to a specific output. Say if 3T, you're going to put 35 kilowatts into a dummy load, and we're going to calculate that. So by the time it gets to the body coil, it's got some loss. It's got some reflected power. But we're going to trend that, and you'll see that because every body coil that's in there that's transmitting has a different efficiency. So there's a different loss on every system. No system's going to be identical. So that data we use. So we're going to trend that. You might see a center frequency start to drift. So, hey, now we've got a magnet that's drifting. What's causing the magnet to drift? That can be an environmental problem.
Right.
Your air conditioning's too cold. It's turning over the air too fast in the room. Now we're putting oscillation into the magnet, and that's bad. So that's kind of the importance why we're collecting that data. We also collect the data on the magnets. We're trending that. We have to watch those. Those are pressure vessels, and we're going to keep an eye on those.
so like I would imagine there's environmental
Plays a huge part in MRI.
yeah, for example, like if weather.
Sure.
Oh, where you're located.
Where you're located, the barometric pressure and humidity. We watch like the gradients and everything are water cooled. The electronics are water cooled. So you have to maintain proper temperatures in there because we don't want condensation build up on anything like that. I've had problems in the past where the body coils just soaked in water because they drove the temperature of the gradient coil too cold and it condensated all inside of there. The problem with that is there's biasing that goes on in the body coil. So you turn the body coil on and off when you transmit and when you scan, and that takes biasing and reverse biasing of diodes, and that's like 1,000 volts of electricity in there. And the system shuts down when it sees a short on that system. So
Imaging Diversified offers monthly support subscriptions with daily phone support. This comes with optional yearly training, a dedicated app specialist, and quarterly image review for your site. Visit our website to sign up today.
So yeah, environmental controls is a big part of it. Keeping that scan room like the same temperature all the time is critical to its stability. And I've fought a lot of that in my day where these new buildings, come 10 o'clock at night, they want to let that room AC shut off, and that's a big problem. We can't do that. You have an 8-ton magnet sitting there, and it's going to warm up.
But an $1,800, electricity bill.
Right,
too.
right. So, and we can talk about that too. I mean, it's incredible how much electricity it takes to run these.
Oh, right.
And even just to maintain the cryogen system. So yeah, there's all
The
kinds
energy
of stuff
cost
like
is huge, right?
Energy cost is pretty expensive.
Well, because helium, which was a shortage, is a shortage, right?
it's always going to be a problem.
Right. And now a lot of scanners, kind of found a way around that a little bit with zero burn off. and
Right.
things like
Well,
that.
yeah. So most of the
helium
magnets-
free.
Helium
Oh, yeah.
free. Well, they have a little bit of helium in there, but they're sealed vessels. So therefore, if they do quench, it's going to stay inside the magnet. It's going to basically burp.
Oh.
And then they're going to re-cool the cryostat and then re-ramp the magnet.
That sounds super safe.
We'll find
If
out.
it's just a burp.
That's the reactor.
I'm like, I don't know how much is in there, and I haven't seen one, and I don't know the specifications on it. But
Right.
yeah, I mean, because we're talking, the 1.5s and 3Ts are anywhere from like 1,600 to 2,000 liter vessels. It's a lot of helium in those. It's expensive.
Well, do you know how much it costs to kind of keep these things cool? Like even with just the temperature, like environment-wise and stuff like that with AC.
Well,
and stuff?
there's the system, and then there's the eternal flame in the magnet, right?
Oh,
So because the magnet has to be at superconducting temperatures, 4.4 degrees Kelvin, right? Because we're
Right.
4 point something, right around there. We liquefy helium
Helium.
gas, right? So there's that chirping. It's the cold head, right? The end of that cold head goes down 4.2 degrees Kelvin, right? So that's where the liquefaction is done. That cold head can only pull out like 1.2 watts of power.
Oh.
So think about your light bulb in your house. If you have a 50, 60 watt light bulb,
Right.
that thing's only extracting 1.2 watts of power to keep that magnet cold. To get that 1 watt out of that magnet, we have to run this big cryocompressor that's 3-phase, 208 volts at 30 amps, and that thing's chugging along 24/7. To cool that, we take a 5-ton chiller. So 5 tons of 5 tons of air conditioning is what you takes to cool your house, and that runs 24/7. So you see the chain there. To get 1 watt of energy out of that magnet takes in end, 5 tons of cooling to get that done.
Wow.
So it's expensive, and that's what we strive to maintain.
Is there a certain amount of time that you can like not hear the chirping, the cold head will be off
Sure.
before it actually quenches?
Well, it shouldn't quench.
Okay.
Okay, that's kind of a
Like
misnomer there.
Okay.
So what you will run into is you'll run into a boil off situation on the magnet. So after like 4 or 5 hours, the vessel pressure is going to go from like this nominal 1 pound of pressure, like on a GE, to 5.25 pounds, and then it's going to start venting. And we want to prevent that. That's our helium going out the roof.
dollar signs.
Dollar signs, yeah.
Yeah.
Essentially. I can't quote you on what it costs anymore, but it's not cheap. So, so you have some window there to get like the cold water or whatever component's bad to go again, and that's why we monitor that stuff, because it's cryogens is like the #1 expense for an OEM
Oh wow.
on their MRIs. It's just
Dang.
that's and they know that, and they try to do everything they can to mitigate that.
So these zero burn off or these lower helium magnets should be cheaper then, huh?
Operational cost wise, yes.
Right.
So in the long term, that's going to be a good thing.
Right.
We'll see.
Exactly.
Good answer.
If we're relying on like 3 or 4 cold heads to return the vessel down to cooling temperature, that can take days.
I see.
We did work on this old O part, and that one was actually cryogenless, but it was like a 0.13 Tesla. It's a refrigerator magnet.
Right.
But it was cryogenless, and it operated basically off a cold head. So, but yeah, hopefully we get to that point.
Sure.
We don't have to deal with that.
Yeah.
And, but there's a lot of expense, and we do track a lot of that data. So that's why it's important that, people are going back and checking the status of their magnet. They're
And
listening
doing it
for the
accurately.
chirp.
Don't just copy and paste what you saw yesterday, right?
Yes, because it can change.
It can
Every day. And in a matter of hours, you can be in a bad situation.
For sure.
So, and getting parts and coordinating all that stuff to change this stuff is a big deal. Like getting helium can be on a normal scheduled out a month in advance,
Oh wow.
because there's only so much allotted for these vendors The government takes all of their helium, and so these fills are scheduled out months in advance. So when you get something like a Quench, it's a logistics problem to rearrange this whole schedule and everybody's fill schedules and get that cryogen back into the magnet and get it cold again. Because the last thing you want to do is let that magnet go warm.
Right.
Then it's a bigger problem. So,
and when you say bigger problem, we talking gradients cracking?
no, it's a bigger problem that the vessel gets too warm, and then you have to get it back down to cryogenic temperatures. And the only way to really do that in the field is shove a whole bunch of cryogens into it, which is very expensive.
Right.
Because what you want it to do is to start to collect in the magnet, which actually turns into a liquid inside the vessel. So otherwise, it's too warm, it just flashes off. It goes out the roof.
Okay. So the only reason why like a gradient would literally crack is from a change of temperature that happens really fast then.
A gradient,
slow, right?
I've had gradients crack, and I think it's a vibrational problem.
Oh.
They're shaking every time you use it, right?
Right.
So they are liquid cooled, and I've had them crack, and that's the largest thing you can change on an MRI as a field replaceable unit. But yeah, we've had them crack, and it's not a fun job.
Right.
It's a 2,000-pound part, and you're going to stick in a tin can. So it's a little tricky. So,
well, one thing, do you guys take the same approach when it's like 1.5 versus 3Ts? I mean, it's the same components,
pretty
right?
much, yeah.
Okay,
Yeah.
so as far as
Basically, the difference to me is the operating frequency of the magnet.
Okay.
Coils, are tuned to each frequency. The big difference, most of the new scanners, the gradients are the same. Same thing, same amp. We're gonna have to make a specific amplifier for 3-tier 1.5. They can have the same slew. It doesn't matter. But the RF amplifier is different. The receive chains, tuned to that frequency. A lot of them are broadband enough to where it's the same thing. Components are the same. And that's nice. The electronics have gotten a lot simpler. We don't have dedicated, 1 Tesla boards, 1.5 and 3T. It's the same stuff.
Right.
No.
I guess it makes it easier for training for one, I would imagine.
Absolutely, yeah.
We touched on environmental issues before,
Sure.
and one thing I think came to as a surprise to me at first is just certain things like what kind of lighting is in the room versus fluorescent, LED, these sort
Sure.
of things, and what that can cause.
Yeah, so I've been in this long enough to go through the whole LED problem.
Oh, nice.
Where, LED lights, the replacement light bulbs were put in there, they're electrically noisy as all get out. And so when they first started coming out, facilities people would come in and jam these light bulbs. They're never going to replace again, right?
Right.
Problem with that is first of all, a lot of the units were illuminated with DC lighting, which takes an incandescent light bulb, which operates on DC voltage, no problem.
Right.
And that's how all these rooms were lit for so long. That was the solution. And then they changed all that, and they put 120 volts through there through a filter. But these light bulbs have rectifier circuits in them, and they're incredibly noisy to the scanner. Scanners hear all that stuff. And then it's simple. I mean, they turn up. They still turn up. Like, I think I had one in a mobile come up not that long ago, and it's like you can tell because there's a slight delay when they turn on. When you flick the lights, you can see which one it is, like really fast. And you take it out, all of a sudden your noise in your scanner is dropped. So your signal to noise, that's everything in MR, right?
Right. Oh, that's everything.
So when you raise your noise way up, then your signal is
Just
decreased. Yeah, you're drowning it. So those become a big problem, and educating people not to put those in there. So MRI lighting, so LEDs used a lot in there now, but all of the power supplies are well shielded and they're outside the room. So and now the scanners are so sensitive, like even the injector power supplies, even though they're shielded, we have to move them outside the room because the scanner picks up that broadband noise. So it's just a little bit, and that's kills it. So we search for stuff like that too. I mean, finding zippers, room leaks, stuff.
I wanted
like
to ask
that.
you about that, like RF shielding and when it's compromised. Like, how do you, as far as the integrity of it, how do you identify the location of that leak?
That's a needle in a haystack a lot of times. So we look for active stuff first. anything that's turned on or powered up in the room. So we'll go in there and kill the power to all that stuff and see if it goes away. If it's still there, what you can do sometimes is like crack the scan room door and see if the amplitude of that goes up. If you can see it, it gets worse. And then you're like, okay, it's an external source.
I'm guessing the door would be the biggest source.
The door is always the biggest source. On occasion, we've had like networking guys shove network cables through waveguides. So that becomes an antenna right into the room.
Right.
But room leaks, yeah, we've worked a lot of times. That's on install is where the leak is discovered, because the scanner won't pass coherent noise or noise studies like that. What I've done in the past is use like surface coils, and you can kind of get a sense of direction of it by moving the coil around as an antenna.
I'm picturing
and pointing it at the
here.
wall. Yeah, and it's
Right.
it's like, so you can do that and watch the amplitude of your signal come up in pre-scan, and you're like, I'm over here somewhere, and that's about as close as I can
Like
get
a little
it.
metal detector.
It
almost,
is, and
right?
it's just like, and we've had these old 4 and those 3 and 5 inch coils
Right.
on like some 50-foot cables, and we do that same thing for like spike noise, which is like the cancer of MRI.
Right.
It's like trying to find that. You'll run around with these little coils and try to pinpoint the source.
Well, so this is kind of off the subject, but I'm
Mhm.
certainly curious. So if you have like a Ferris object that's breach zone 4 and you've got
Yes.
it attached to the magnet and you
Mhm.
get that call from the tech or supervisor, whoever it may be,
Right.
what's step 1 all the way through?
All right, I put the work order in. Step
That's
one.
when you call in sick that day.
Yeah.
Somebody else's problem. It really kind of depends on the object, what we're dealing with. But first and foremost is try to secure it. Make sure it's not gonna, if it's in the bore or if it's attached to the magnet, you don't want to keep it from going into the bore. I've been on a bunch of those calls where things are stuck to the magnet, and some of the OEMs have rules as to what you're allowed to do,
right.
like how many bodies you can put on that thing to try to get it off the magnet.
Oh, they have a rule like that? Like how many people can help you pull it off the magnet?
Yeah.
What about the size of their muscles?
It doesn't. They don't quantify that. So
I'm going to Gold's Gym first.
since right, exactly. So I'm not that big, so I count as half a person. So
So we got a whole person right here.
right. But we've had to put like plywood and stuff in front of the bore to keep things from going apart. Stuff like that. It's just securing.
What's some of the most common and most unusual ones you've seen attached?
We've had,
Ballpoint pen.
Well, so like when we were the Sun City sites, it was like a lot of paper clips in the bore, or hairpins. Those things just
And they get lost, like embedded in the
super
table
fast,
and
right? Yeah, they're
stuff?
everywhere. And so like the old GEs, they have the bridge in there. So every field service guy has a screwdriver about this long with a hook on the end to try to pull those things out. And right
Sounds
when
like
you
a
get it to
scary
the
movie.
end, it shoots right back into the other side and you're starting all over. But so yeah, we've had like laundry carts in there, like linen carts stuck to the magnet. I was involved with a wheelchair in Utah stuck to the magnet. I've had a contractor stuck to a magnet. His tool belt was stuck on the magnet.
And they didn't quench it?
No. So, well, the one in Utah where the wheelchair got stuck to it, it quenched the magnet.
I'm guessing there was nobody in the wheelchair?
Nobody was in the wheelchair. The wheelchair, I don't know why the wheelchair got took in there. It was not an MR safe
for
wheelchair. It actually killed the magnet.
Oh.
So, one thing to know about magnets is the vessel is just the vessel, and the magnet is thermally isolated inside. It hangs basically inside of there on fiberglass rods. So anytime something's stuck to the front of it, that magnet inside is pulling to that. And what happened on that one is it broke those fiberglass rods, and the main coil basically fell.
Just fell. Oh.
And then when that happens, it becomes a thermal short, and it's over. It's done. And that's what happened to that magnet. When they did finally, so the wheelchair fell off. When they tried to re-ramp the magnet, they had no connectivity to the main coil, and the magnet's toast. So you have to replace the whole magnet.
Talk about a paperweight.
That's a
Gee.
really heavy paperweight. So, yeah. So with some precious metals in there too. So
Okay, so pretty common healthcare things.
pretty
you would see,
common, yeah. I mean,
but like any guns you've seen?
guns. There was somebody with an ankle holster that got through screening, and his leg got sucked to the side of the magnet. Canes are a big thing. See a lot of those stuck to the magnet. And these things fly in so fast, they kind of break parts as they go in. I have wash buckets. I don't know how those things have cracked whole front covers, and they hit so hard when they go in there, and just you name
mops
it.
And
mops.
brooms.
I did an install once where the installs is where a lot of this stuff happens, I think. A lot of things, because there's always contractors that have to go back into the room for a little bit of work, a little touch-up work. And
so it's important to know that your tools are different than their tools.
Yeah, we use MR safe non-mag tools, so mostly titanium. Like I had a paint roller stuck in there. I had caulking gun stuck in there, and the guy tried to keep pulling it out, so he's pushing caulk all over inside the magnet. So, like the paint roller's rolling around in there, and it's getting paint all over the inside of this, brand new scanner. And it's just like, this is a disaster. So,
Right. Well, I mean, it's like you work on multiple types of equipment that we have in that space, right?
Sure.
Like power injector, like you were saying.
Absolutely, yep.
The pump, like the medication pump and stuff like that. Do you find that things that are made to be in that room break easier than things that aren't? Like, is there something about MRI items?
I don't think so. Most of that stuff's designed now to be safe in that environment. Yeah, I don't see any correlation. No,
like that,
like the injectors, they're just filled with GAD most of the time, and that causes all the problems. That stuff turns to stone and everything.
Big mess.
Right, and it's just like that's most of the problem with those things. So
I think mostly nowadays too is fiber optic, right?
everything most in and out of the room is fiber optic as much as possible for communication. Right. It's just cleaner. Its immunity to noise is a huge plus. Even the newer electronics in the equipment rooms, almost all of that stuff is fiber optic now. So everything like going to and from the gradients, instead of having a big sub D connector, shielded cable, it's fiber optic now. So everything is converted to fiber optic, and it's just so much better.
Right.
Now, is it just sitting in place or is it fixed? Because I've heard of stories of like the magnet actually walking.
Oh, yeah.
The magnet shouldn't walk. I've never heard of that.
There's a steel beam in the wrong place.
Was it with
happened.
Tobias that we had
Yeah.
it? Put the link right there. We actually had Tobias Gilk on, and he was talking about an
And
incident where that happened.
It was like slowly
Slowly?
Where they noticed they'd come back the next day and it moved like 2 inches.
Yeah,
kind of thing.
I've heard of problems where they discovered that there's like a big steel beam under there that they didn't know about. And maybe it was something like that.
Yeah.
So, because a magnet, when you bring a magnet up, it kind of conforms everything in that area. So your shim will like change after 6 months once it kind of magnetizes everything in its direction that it wants. So usually after an install, you have to come back and kind of touch the shim a little bit, make sure that's good.
Yeah.
So,
it's interesting. I've always thought about, and this is a little off subject and me nerding out real quick with Todd, but I always thought about force fields and how it's just kind of like, how you have your magnetic field? It's just like a reverse magnetic field that protects everything on the inside, pushes everything away.
pushes everything away. We wish we had that. Keep everything out of there.
I know, right?
You're not getting past.
Yeah, right.
No.
So we're talking about quenches, spontaneous ones and unplanned ones. I'm curious about, so when these quenches do happen, what's the difference between, as far as logistics goes, of bringing it back up if it's a planned one and you're ramping it down versus a like an actual breach of a Ferris object and you've got to quench the machine?
In recovering of the magnet, it's the same. So normally we try to ramp magnets down. So
Meaning
slow and controlled. We're not going to blow the burst disc out of this thing. We're going to use a minimal amount of helium to do that. So we like to do that. That's our preference. But unfortunately, quenches do happen.
Right.
And most of the time, they're called training quenches. And they're unexplainable. Like all your data will look fabulous until that thing let go. And a lot of times, It's like the winding shift in the magnet. And there's been some improvements in the newer magnets to try to stop that. But yeah, sometimes they just quench, and you can't explain it.
I'm sure you've seen a few. I actually
I've quenched a few.
unknowingly saw one just within the past year or so. I was at a place, and all of a sudden they just said, "Hey, the magnet just quenched." And I looked in the room, and nothing looked different to me. So
No,
it was,
yeah.
you know, you're told all these things to expect, but I didn't
That's
see any of
perfect.
that.
All the safety stuff worked.
Okay.
So
okay.
you'll like we had one quench. Nobody knew it quenched. I walked up and I seen all the error message on the screen. I was like, oh, this is not good. So grab a wrench. We're going to go test the field.
Oh God.
And sure enough, there's no field. And when you pull the covers off, you see the ice block up there. And it's like, oh, yeah, she's gone. So as far as recovering that, you know, you try to seal the vessel up as fast as you can. What happens is it's called cryo pumping. It sucks atmospheric air into the vessel, and that's bad. Nitrogen and oxygen freeze pretty close to each other, but it freezes a lot sooner than helium. So that causes ice blocks in magnets. And ice is very dangerous when it comes to magnets. You don't want ice built up in your magnets. That's a controlled pressure vessel. It can be a pressure bomb. So we want to regulate the pressure and maintain that. Ice is a problem because it blocks the safety mechanisms. I've cored through magnets at 7 and 8 pounds to get them to release that pressure because it's full of ice. It's very dangerous. That's 2,000 liter vessel. I have some data that I probably can't share. How much pressure a vessel can take before they explode. Yeah, it's critical that people maintain that because that's what's going on. It's a pressurized vessel and you need to take it serious. But ice is a big problem. So you want to seal the vessel, and then you want to get cryogens in as soon as you can and keep the cold head running to make sure the vessel doesn't heat up. Because that's going to affect how much helium product you put in there before it starts to
What's
collect.
the downtime on something like that? Assuming
Average. I
all your
guess.
ducks are in a row and
All your ducks in a row. I mean, we had a miraculous recovery. I've never seen one that fast at the hospital, where basically the thing quenched, and within hours there was a truck driving past, basically with dewars in it, and they told him to turn around and come back and fill this thing up.
Oh, that's funny.
But it still takes like a day or two to get like the ramp equipment in there. And when you ramp a magnet, if you don't park it really, really close to where that frequency was before, you might have to touch the shim up in the magnet. So you might need more equipment to come in to correct the shim. Luckily, they parked it so close, the shim was actually better than what it was before. So there, I mean, you can be down a week easy from a quench if you can't get product in there fast enough.
well, there's a reason why we invited you. You're very knowledgeable. Healthcare in itself is not a static industry, right? It's always evolving. We're
absolutely.
expected to do continuing education. Are you guys also doing continuing education?
No, we're kind of just do product specific education. So you're kind of up to speed on the product you're working on. So
So every time there's a new product.
every time you get a new product and you're responsible for it, you should be trained on it.
So are you guys, like, we're getting apps training, you know, right? Are you guys getting direct training from the vendors when
That's
these
where
new?
we got our training from our vendor.
Okay.
So yeah.
And is it on-site training, or do you guys go
No,
to
we
them?
usually have to go there because it's a lot of hands-on training. There's a lot of lab time with these classes, so you get to take things apart, you know, on their system, not our system,
Right.
because we can't afford that downtime. But that's how our training is completed. So
Nice.
yeah.
I guess we're kind of just sort of wrapping up, right? I am curious about and this is dependent on where you work and whatnot,
Sure.
but like you specifically, what's your call requirements?
Call requirements is how many people are willing to take call and how many people we have in our department. So our call requirements is like every 8 weeks, I think right now, 8, something like that. But we're basically 4 p.m. to 7 a.m. is our call, and all weekend long. So whatever time of the night.
And then how often are you guys getting called in?
I'm on call like every 8 weeks, but it depends. I mean, sometimes you don't get any calls. Last time I was on call, they pulled me in at 2:00 in the morning for a CT, stuff like that.
So you're still servicing CT.
We'll triage it.
And I understand that this is all really dependent on
Sure.
you as an individual, your place of employment.
Right. So, well, yeah, then it's mostly hospitals are like that. So, and we can touch upon that, why hospitals are now all going to this in-house kind of stuff.
Yeah.
But yeah, the response time of having your own people is so much better.
I'm guessing response time is the answer,
It's
right?
absolutely. It's 100% that, because it's time, and that's what we're all fighting here, right?
Right.
So,
Oh, yeah.
so I don't need to be an expert in that modality. I just need to know if there's not something I can turn on or reset. Then I'm calling somebody else up or calling it down.
Right.
And,
Did you turn it off and turn it back on?
Yeah. Do that measurement. Call that level 10 reset.
Yeah.
Well, I just wish I had your mindset. I feel like you could fix anything.
No,
Your
for
toaster
real.
at home breaks, you're fixing it. You're not buying anything.
Well, that's the thing, is that that's part of the problem with finding people that do this job is, we've kind of become like a disposable society, and this is a complicated piece of equipment, and we're not going to just throw parts at it. We need to be, and they're expensive parts, right? It's like, so we need to be definitive when we're swapping things out.
For sure.
Katie, do you feel like we haven't covered anything? Do you feel like we haven't covered anything?
I don't know. What else do you want to talk about?
I when you work at a place that has multiple like vendors, but not just multiple vendors, but even multiple scanners from the same vendors, and you're interchanging coils and tables, like how does that all work? Can any coil be used on any scanner, or do you have to configure it?
How transferable are the tables?
Yeah.
Well, those are like system specific. So like we can't take a Sola table and put it on the Skyras.
Okay.
It's just, they're
Right.
different, right?
Right.
We can't take 1.5 coils and use them on a 3T. They're tuned to different frequencies, right?
Right.
So and the bandwidth of the coil is just that. So it doesn't have that ability to do that electronically. So yeah, we're working on like getting all of our tables. Each one of them has like a calibration file, so it's transferable. We just register the tables to other scanners, and then they work. So, and we try to make sure that all three of those, are working on all scanners. So, and when it comes to coils, you can take a coil and 3T to 3T. It's no problem. It doesn't have to be registered on the system. That's
like
for
from one skyro to another skyro.
Right, and you don't have to register it on the system. It will function and scan fine. It only needs to be registered on the system in order to provide a QA file. So if you want to run a quality assurance on that stuff, then therefore it needs to be registered on there, so it creates a proper file with that serial number. So yeah.
Okay. And when you say proper file, like if we're doing that report, say an issue happens, what's that report called? That we
report
hit?
manager on there.
Or that takes a long time every time that we do it.
Like the save log.
Yeah.
On there.
Does that matter with that coil? Like, will it not do a
It-
proper save log if that coil doesn't assign to that table? Or test
No,
scanner?
it should capture that.
Oh, okay.
So
So like a higher level QC is what you're saying.
yeah, this is where I want to make sure that the coil's passing all its SNR. So
Okay.
every element in there has a specific SNR that it needs to meet. So
Right.
otherwise it fails the QA. So
Cool.
yeah.
Yeah, thanks, man.
Well, like there's always up and coming things that we're at Tech's excited about, like as far as technology and upgrades and whatnot. What are you seeing on the horizon that you're excited about?
The new stuff to me is like Air Recon DL and deep learning.
yeah.
That's kind of the new thing out there right now. I think once we get that, along with a little bit more API stuff, I think MR is going to kind of be a volumetric kind of acquisition.
Right.
API's come a long way in 10 years. So I think we're getting to that where we can acquire so many echoes at one time that that's all we're going to do. So we're going to acquire a bunch of stuff and post-process it later.
Post-process.
Yeah,
All right.
and I think it's going to take a while to get there, but I mean I believe that's where we're going in MRI.
Nice.
And you don't have to give the details as to why, if so, but have you ever had an MRI?
Oh, I have had a lot of MRIs.
Have you?
Yeah.
Just as in the working environment or as a patient?
Both.
Okay.
So yeah, we used to be allowed to.
What
do
a
that.
perspective as you're sitting there listening to the pre-scans and
It
stuff.
is, and it's just like I know what it's doing right now, and
don't
it's
sound
so
right.
it's so funny. It's just like because he's mentioned that I remember the first time I got, well, one of the first times that, like I experienced Cube,
nice.
when that sequence came out several years ago. I mean, like
It's loud.
that thing was shaking the whole scanner,
Right.
right? And I'm like, they're scanning my knee, and I'm just like, okay, you have to tell me what that last one was because I've never heard anything like
Right.
that before. And it was just like, but I can tell by the gradient pulses as to how far along I am in the scan. I don't need to hear the clock, and I hear it switching, and I'm like, okay, now it's trending the other way, and so I'm listening for that kind of stuff in there.
So you don't request music then?
No, I want to hear the sweet sounds of the gradients.
Sweet sounds of the gradient.
I think you're going to do the next rap song for us, Todd.
I don't have any talent.
All right. So I guess one question we always do ask some of our guests, or we try to ask everyone, is what has been the most fulfilling moment in your healthcare career?
Oh man, fulfilling moment. Jeez.
Solving a problem no one else could.
Pulling that
Somebody will-
contractor off the magnet?
Pulling a contract off the bag. I don't know. I haven't given that a whole lot of thought.
We put you on the spot. This is the first time you haven't been able to answer a question,
I
Todd.
know,
right?
right?
I don't know. I did have one patient come out one time, and he asked, he's like, that thing makes a lot of noise, and he's like, there must be a lot of moving parts in there. And he was an engineer, and they were like, well, the engineer's right there. You can talk to him. So I kind of talked to him, and he was like really impressive. He's like, I'm like, there's really no moving parts in there. Like,
Right.
the table that pushed you in there is it, and everything else is electrical noise.
Right.
I'm like, that's like a bolt of lightning going off around you, energizing that coil every time it fires.
That's a good way to put it. Like the way, because we were asked that question a lot. Like,
Yeah.
is there moving parts? Why is it so loud? And I usually just say that like that's the current changing directions and
Sure.
stuff.
Yeah, it's an inrush of current, and that's like a lightning bolt going off in there. It happens at the speed of light, and it's basically being dead shorted into a coil,
Right.
and that's your disruption of your field. And that's the Big Bang. So the Big Bang of MRI. So,
That's our
you know.
clip right there, Reggie. All right. Well,
I'm
I
not giving you
think
too much.
I don't know, Katie.
Any other
Yeah,
questions,
I think-
Katie?
Come on.
You got anything for me?
I've been very excited about this episode, by the way, for a
Oh,
while. So
We
thank
all
you.
have. We
This
all
is
have.
so boring.
No, you're a humble man.
Good job.
You're also a very smart man. So thank you for
I know,
coming
man.
in, Todd. We
Thank you,
appreciate
Todd.
you.
We do
You're
appreciate
welcome.
And I guess we're going to do the shout. So this is when we wrap it up, right? So thank you for watching Zone 3 Podcast. Thank you for subscribing. Tell your friends to as well. Do all those things that YouTubers tell you to do. Reggie.
Zone 3, we are out.